Anyway, number 2. Pi over 4 plus 2n pi, and 3 pi over 4 plus 2n pi, and 5 pi over 4 plus 2n pi, and 4 is pi over 4 plus n pi. Number 6 is, excuse me, 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi. Number 8 is pi over 3 plus 2n pi, and 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. Number 10 is pi over 2 plus 2n pi, and 3 pi over 2 plus 2n pi. And 12 is pi over 6 plus 2 pi n, and 11 pi over 6 plus 2n pi. What questions do we have over those?
I keep not knowing which reference angle to put. Because, like, how many you're supposed to have.
It depends on, like, it's positives and negatives. Yeah. Is there one that it seemed like you're, like, particularly off on that we want to start with? We'll start with 8. 8's got a lot of stuff. Okay, number 8 is 11 equals 3 times the cosecant squared x plus 7. I love that idea. Let's do it. Say the good silver lining, Alexa, is that I think you actually kind of understand this. So maybe accidentally doing the wrong thing won't totally fry you.
I don't know. I somehow can't understand
Number 2, yeah, we'll look at it. Probably. 11 minus 7 is 4 equals 3 cosecant squared x. 5 by 3. And we end up with the cosecant squared x equals 4/3. What am I writing? Square root both sides. And we end up with the cosecant of x equals plus or minus 2 over the square root of 3, which equals plus or minus 2 times the square root of 3 over 3. I just rationalize it, just depending on how you're thinking about it.
Oh, so it's not gonna, because it's cosecant, it's not gonna flip to sine?
You could do that, but you don't have to.
Okay, but then when it becomes
Square root of 3 over 2. Yeah, if it's easy, yeah, so this whole thing could turn into, well, turn into 1 over sine. Oh, equals that. And then, yeah, so we flip it all. Yeah, I see. Yeah. That's fine. Totally fine. Not a problem. Yeah.
Wait. Why are we flipping it?
Because we know that. We know the sine, where the sine is the square root of 3 over 2. We can figure out where the cosecant is, but this one we should have memorized.
Oh, yeah.
And it's plus or minus, so it's all 4 quadrants.
Yeah, that's what I messed up.
So it's
Yeah.
going to be pi over 3 plus 2 pi
Yes.
and then
Oh, I forgot
pi over 3 quadrant plus, okay.
Yeah.
This is gonna make me very angry.
You do number 2 then because I thought
Something happened? Sure. Let's do 2. We are, by the way, nobody has seemed worried about it. So, there it is. But in spite of slowing down a little, we are...
I just needed to do the flippy thing.
Great. In spite of slowing down a little, we are about a chapter ahead of both Talkington and KPA in pre-cal. So we are doing just fine. Now, we're not going to like slow way down because there might be a place where we like break and everybody's sick or whatever. We're going to keep going, but we are doing well, which is great.
What was it called?
I don't know. What is it called? Somebody donated a calculator on accident. Good job. We didn't. Do we need to do 4?
Yeah, because that's the only one where I didn't make the square root mistake, and I'll load it.
Okay. 4 times the tangent of x minus 7 equals 3 times the tangent of x minus 6.
You guys subtracted 3 tangent x on both sides and added 7 x on both sides.
Sounds like a good idea. So you ended up with the tangent of x equals 1. Unless I'm greatly mistaken, you did not end up with that.
Yeah. Well, I got 1 equals negative tangent of x. So
Did you do it reverse?
I did plus 6, and then I did minus 4 tangent.
So if you did that, what you should, you still made a sign mistake. Because what you should have ended up is negative 1 equals negative tangent of x. And then you would have multiplied or divided everything by negative 1 to get positive. Okay, so this is the tangent one here, tangent of 1. This is, I think we did one, I think the one we did in class was cotangent. But it still has 4 answers. What is tangent?
Sine over cosine.
Sine over cosine. It's also y over x, right? So it's 1 over 1, right?
Yep.
Wait, does it have 4 answers or 3? One, 2, 3, 4. The book is telling us that it's all of those. But it is not all of those. That's not true.
What is that sound?
Because tangent isn't positive here or here.
Is it like trying to?
No, I think it's a mistake or we did something wrong. No, it's just tangent. If it was this, then it would be all 4 of those. So maybe they thought they put a squared. So
Square root and then
yeah. Yeah, and then it'd be plus or minus 1. And then it'd be all 4. But what it actually is without the squared is only that one and that one. Because that's where tangent's positive.
Why is tangent positive in the top right?
'Cause it only-
Everything's positive in
There.
quadrant 1.
Don't take your time. It's Italian. It's okay.
My brain is.
Yeah, so it'd be
I did the blue.
pi over 4 and 5 pi over 4. Both plus
Yeah.
pi in. Yeah?
Did we get there again? I'm sorry.
What was the second one you said?
How do we get which part? Like from here to here or from here to like what the answers are?
From the beginning to.
Well, that's just algebra. You know how to do that, yeah?
Yeah, but then we have a. We can just. I'm just confused because the numbers don't just cancel fully out. I'm not sure. I'm not sure why.
This is what I did without writing.
Right.
So, what I don't understand
Okay.
is how, like, All of Bree's answer is in this form. I forgot what that form is called.
Yeah, in radians.
Well, no, with like the E, the weird E, and then the integers.
So it's meant
Where
there.
do I go to look at to remember that? Because I need to.
The notes from Tuesday.
From.
Are they all?
from
And or the
Tuesday?
book.
We did that in the notes from Tuesday.
Yeah, we did.
Are they all
So if I have 3?
integers, or they imaginary?
Yeah. Yeah, they are, all are. Mm-hmm.
So it's just-
What was the answer to the bottom left quadrant?
It would be 5 pi over 4 plus 2 n, 2 pi n.
Wouldn't it just be pi in?
Oh, yes, my bad. Thank you. I caught that when I said it out loud, but then when I went to write it on the board, I uncaught it.
And I have a question, like for the test, if we come in with like a blank piece of paper and then we write down like the radian circle in the chart, is
Yeah, you can't come in with it already on there, but like as soon as I hand you the test, yeah, if you want to that's always a wide idea. Brain dump the whatever. I am about 60% sure at this point that I will give you some amount of a identities chart.
That'd be amazing.
What I'm leaning towards, I would still work to memorize them because if you have if they're more top of mind, then you're going to remember which ones, and it's going to be easier. It'll be easier to solve the problems. Like if you have them at least pretty much memorized. So I would still work to memorize them. That's why I'm not 100% sure, and I'm not 90% sure. I'm 60% sure that I'm going to give you something. And what I'm leaning towards is giving you one that has the ugly ones, like the ones we're going to start learning today, well, or maybe Tuesday actually, but some of the ugly ones, like the Pythagorean identity ones, I don't know that I'm going to have those on a chart. Everything Pythagorean identity and before, I don't know that I'm going to give you those on a chart. And mostly because of what I just said, because they're used so often that memorizing them is really going to help you like make the problems easier. Really, so it's not just to be torturous. It's more just to try to oot you into doing something that'll make the test easier and you'll have to cry less. Okay. Any other questions from this chunk before we finish this lesson? Probably.
What, never mind.
Okay.
The bottom left answer is just pi plus pi over 4.
top right?
Yeah, I mean, you usually write that. So it'd be pi over 4 plus pi n, yeah?
What are the answers to 6
Bottom
again?
left one.
6
Bottom left is the thing, bottom left.
Yeah, how do we get that?
pi plus the reference angle.
Okay.
Number 6, the answers are 2 pi over 3 plus 2 n pi and 4 pi over 3 plus 2 n pi. Let's finish this lesson up. I think we really just have like 2 more. Well, yeah, we probably should do all this. Okay, we just have a few examples, and then we'll do some homework, and I think we'll have time to get started on the next lesson, but we'll see. We're going to find all the solutions to 2 sine x cosine x equals square root of 2 times cosine x. And we're going to find all the solutions on the interval 0 to 2 pi. And including 0, not 2 pi. The instructions are in the middle of page 328 if you want to see with your eyeballs how that's written. Okay, so we don't, so when what, and the, I'll let y'all finish copying and then I'll say words so you can hear.
Oh, sin x, not sin times. I was
Yeah.
confused.
Why did you write times like that?
Two cosine x.
Okay. So what that means, the instructions where we're finding it on the interval from 0 to 2 pi, basically all that means is you don't have to do the plus 2 pi n nonsense and the pi n nonsense. You just list them, right? That's basically what's happening. So what could we do?
Did that part came, that part came from the instructions?
Yeah, that's the, oh, you didn't flip there, whatever. Yeah, that part did come from the instructions, yes. So we can't just divide off cosine. Wait, this is not that kind, just kidding. Yeah, we can't, yeah. Because, yeah, no, you're right, sorry. Brain wasn't braining perhaps. We can't because we're going to lose some of our answers. So we'll have to do this a little bit more complexedly because we have to figure out the answers for like sine and cosine.
Okay, then.
So we can't.
We can't just divide by cosine and poof it away because we're going to lose some answers if we do that. So what we can do is subtract square root of 2 cosine x from both sides. We're about to do the big F word. That was a funny joke. It was so hilarious. It might even help you figure out what we're going to do next, but we'll see. We are going to factor. Look at y'all being smart.
I thought it was foil, to be honest.
That's almost the same, right? It's the other way around. So, what can we do on the left side?
You're subtracting, not dividing.
Thank you. I don't know, because brain isn't working, I guess. I don't know. What now? Factor a what?
There's no squares.
You can factor it to be 2 sine x times 2 cosine x. If you want to be silly. No.
I'm confused what you're saying.
No, that's a whole
Factor out a cosine?
Yeah.
We can factor out a cosine. Just GCF in it. It's going to be okay. Now what could we do?
Why is the negative square root 2?
I don't know, because I keep forgetting to write things. Now what could we do?
Do we need to move something back to the other side?
Nope.
Can we divide the inner unit by 2? No?
Not yet. What that's coming. It's completely factored and equal to 0. What can we do?
It means that it's nothing, it's equal to 0.
Something in.
So cosine is equal to 0?
When something's factored, it doesn't even have to be completely. When something's factored and equal to 0, we can set each factor equal to 0. This one, we'll deal with in a second. Let's clean this one up. What should we do? That's easy. Sine x equals square root 2 over 2.
So that's pi over 4.
When is cosine equal to 0?
Pi over 2.
At pi over 2, that's true. I don't know why I'm thinking that.
Things can be equal to 0.
And then the other one is at pi over 4.
Pi over 4. And where else?
One second.
Okay, sorry, I was writing. Can you go back to what you said, like 10
When is cosine equal to 0? Memorize the chart, but you may need to look at the chart.
Oh, yes. Okay, understood. I've been working.
It's here. Like when you go check the chart, it's here.
Okay, 3 pi over 4.
Where did we get pi over 4 from?
Where else?
Square root of 2 over 2.
I should have left him more gap because I. Where else is cosine equals 0?
The 0 thing? The
250 degrees.
3 pi over 2?
Yes.
When did G
What is cosine? Is it x or y?
It's X.
X over r, right? So at pi over 2 is equal to 0. And at 3 pi over 2.
And so where's the pi over 4 and the 3 pi over 4?
That's when sine is square root of 2 over 2.
And so on sine, are we counting the points on the either side of the horizontal line?
What? When is, okay, let me see if I can hopefully answer your question by diving in. You tell me, when is the sine of x equal to the square root of 2 over 2?
You get pi over 4.
Pi over 4, which is like right there.
And then it's pi minus pi over 4.
Plus, because it's sine. No, you're right, minus, you're right, because it's sine. But yeah, because it's over here, all students. Yeah. Let's do another one that's kind of like that one, but arguably a little uglier.
3b.
That's exactly what we're going to do.
You might know that.
All right. Pretty much all the rest of these are like, okay, how can we manipulate stuff with algebra? And then do a little tiny bit of trig at the end.
The answer is 3 pi over 2, right?
Yes, sir. Yes, sir. 4 cosine squared x plus 2 cosine x minus 2 times the square root of 2 cosine x, right? No, yes. Oh, interesting. This is not going to be solved the way I thought it was. Okay. It's going to be kind of easier than what I thought we were about to do.
Can we factor out the cosine?
I think that's a great idea. I thought we were going to have to factor a trinomial, but we're not. We can factor.
1 cosine that we you can't
I will, what I was distracted about in that moment, I'll go ahead and say, so it's out of my brain and not distracting me anymore. I don't know whether any of y'all are going to end up taking calculus in college or not. I suspect at least 2 of you will, based on what the projected majors are. I will tell you that, I will tell you, I'm going to stop writing and finish my sentence. I will tell you that 80% or more of the people who struggle in calculus do not struggle with the calculus. Calculus is easy. What they struggle with, if they struggle with anything, is the algebra and or the trig. So, be glad you're taking this class. Continue.
This is trig, right? Or is this...
This right now is trig that we're learning.
What is calculus?
Study of ugly areas.
That's a philosophy question more than math.
No, it's not. Okay, now what?
Can we move the 2 square root of 2 up to the right?
We can't yet. Why can we not yet?
Because it's... I have the words in my brain, I can't.
It's trapped in the parentheses, right? So what can we do instead?
Is there any, we can't combine anything inside, right?
No.
Oh, you know, we did this. We didn't really take a very good first step. It dawns on me we didn't, that's kind of true.
Okay.
Then do we just restart?
Should we restart?
Probably, because I was about to say, it's factored and equal to 0, but then it's not.
So should we have moved the 2 to the other side first?
Which of the two?
Okay, so this problem is even uglier than, so I retract my first statement. This problem is actually uglier than what I first thought. What I first thought was a cakewalk compared to what we actually need to do.
Just distribute instead?
We need to combine like terms.
What like terms?
Commas.
Okay, there's 2 that have a single cosine.
But when we combine like terms, it's going to look a little ugly, right?
4 cosine squared x plus 2 minus 2 square root 2 cosine x equals square root 2. Yeah, that is how I thought how math worked.
That's, oh my gosh, this problem is way uglier than I thought. It's not going to be that hard, but it's going to be a little confusing. We got this.
Okay, that means like, just comprehend what just happened.
Can we now move?
When you let me help you comprehend what just happened, Garrett. You ready?
I figured it out.
Okay, just kidding. Okay,
I just think we're a little slower than most students. So.
I think you just write slower, because half the time.
Other colors in your math.
I haven't been written another color. Not here, I did.
Other colors are a good plan, like very good plan. Okay, so what I was going to say, before I was going to say something else, and now I'm going to say the first thing again, is this is a quadratic,
Oh, fine.
right? We only know 3 methods to solve a quadratic, right? Believe it or not, this one, unless I'm greatly mistaken, factors.
In what nonsensical world does this factor?
Let's give it a shot. And believe it or not, I honestly kind of think factoring this is going to be easier to understand than trying to do the quadratic formula on it.
What is the quadratic formula? All these words.
It does, but with all those square roots in there and another square root that we're adding and other things, it's going to get ugly in a hurry. Well, no, because we don't want decimals. So you wouldn't even, like a calculator would be useless, right? If this problem showed up on a test, and this problem would not, but if it did, it would be on the no calculator portion. So.
Alright. So what can we subtract that from?
Nothing, just it's going to hang out.
Okay, just gonna be friendly. It's not friendly.
I should look at the example in the book and see if there's not an easier way to do this that is not coming to my brain first before we continue down this path. Because I'm not seeing another way to solve it. But if there's something that tells me that there's another way to solve it, we could do that instead. Let's see. Nope, this is basically what they did on that one, so I don't think I'm wrong.
Okay, so it's gonna be 2 parentheses, right?
Yes.
Is it gonna be 2 cosine x in the first?
Yeah, that's the easy one, right?
Wait, but how does,
The first is easy, right? The first slot is easy. It's going to be 2 cosine x times 2 cosine x. No problemo. Great.
Okay, plus 1 and minus square root of 2.
Let's see if it works.
it's 2 minus 2 squared root of 2. Does that have like an actual answer?
2 times 2, 1 is 2. And 2 times negative square root of 2 is negative
Oh yeah, that works.
2 times the square root of 2. Can we add or subtract those to get 2 minus square root of 2? I didn't really mean to write the sign yet, but that's fine. We're going to put it in there in just a second. Can we, what am I writing? Can we add or subtract those to get this?
Yes.
Yes, we can. What do the signs need to be?
Plus, minus.
Plus, minus. We follow our nose. We follow our mouth. And whoop-de-doo, it factored.
So we have 2 cosine x plus 1 and 2 cosine x.
And just ponder for just half a second what plugging these into the quadratic formula would have done to our life. And bask in the fact that I was not wrong, that this was way easier to understand than that. Now what can we do?
Is there ever going to be a thing where we're going to practice something like that?
So, I wouldn't put one like this on the test. I probably will put one on the test that you have to factor. But it'll be integers, not irrationals. Although honestly, this might be easier. But yeah, we almost certainly will have one on the test where you have to factor it, because that is absolutely a classic problem that if you do any more math in college that has trig in it, you will have to factor something with trig functions in it. That will happen for sure. So we'll almost certainly do that. Anyway, so 2 cosine x plus 1 equals 0.
So we
Cosine x equals negative 1/2. And 2 cosine x minus square root of 2 equals 0. So the cosine of x equals square root of 2 over 2, positive.
okay, so that bottom one, we're going to have pi over 4 and 5 pi over 4.
Probably so. So where is cosine negative 1/2?
Okay, so it's x over r. So negative x is on the left, positive radius, so quadrant 2.
Quadrant 2 and
So quadrant 3.
quadrant 3. So where is in quadrant 1, that's coming from our chart, where is cosine 1/2?
Pi over 3.
Pi over 3. Where is it with the reference angle pi over 3 in quadrant 2?
4 pi over 3? No, that's not how math works.
That'd be over here.
This would be pi minus the.
Pi over 3.
Mm-hmm.
So pi over 3 plus.
That's 2 pi over 3.
It is 2 pi over 3. 2 pi over 3. And then in quadrant 3,
5 pi over 3?
5 pi over 3. Is it? No?
Oh, I'm having issues with that.
4 pi over 3.
4 pi over 3. Hey, that's from this one. Now,
Are you sure?
am I sure of
No, I'm doing this wrong. I think.
so it will be pi plus pi over 3,
Yes.
right? So 3 pi over 3 plus pi over 3 is 4 pi over 3, right? Good. Okay. Now, where's cosine positive? The other two, right? Where is cosine square root of 2 over 2?
Pi over 4.
Pi over 4. And then in quadrant 4, what would it be?
7 pi over 4?
It'd be 2 pi minus pi over 4.
Yes, it would be, which would be 8 pi over 4 minus pi over 4, which would be 7 pi over 4. You got your mojo back.
I like algebra. In some.
This lesson is mostly algebra, TBH. This last little bit is the only trig that exists in this particular lesson. Most of this lesson is algebra. How are we doing? Making sense? For once? That's not true. Maybe it feels like for once in this unit. This is the best unit ever. What are we at? This is at unit 5? Yeah. That's awesome. How far are we going to get in this thing? Let's make a prediction. Let's find out. In pre-cal? I didn't have pre-cal last year. Oh. Algebra 2, we got into 9, but barely.
Well, like halfway through the year, I'm already at 5.
Yeah, well, you don't expect to get through all of them. In almost all math books, the last few units or / chapters, whatever they call them, are like past the class. In most books in this particular curriculum, I find that generally speaking, if you get through 8, you're usually like easily good. Anything after that is bonus. I do think so too. We're going to actually learn conics for real. Oh, we're about to do, oh, this is going to be fun. Oh, this is, we're going to go back to systems. You know what's really awesome is we're going to learn how to do reduced row echelon form, and we're in pre-cal, so that means that you're going to learn how to stick it in the calculator and push enter. You'll have to suffer through doing it by hand first, but
Is there going to be a no calculator portion in that?
no, only during trig. And then conics, that's fun. More
It sounds like phonics, but that's incorrect.
What time is it? Do I have time to like ramble for a second or not really? Just barely. Conics, real quickly, because pictures, thank you, are slicing this shape with planes and seeing what shapes happen.
Oh, fun.
Which we did learn some. Y'all remember from last year? We did learn a little. We talked a little bit about ellipses and a little bit about circles. We talked about this, but only barely.
I feel like you said that was a thing, but you won't get to.
No, we did. We did get into 9 just barely. We didn't. It wasn't on the final, if I remember right. That I may be remembering wrong. Oh, here's your phone back.
Yeah, we didn't do it. But I remember
We will certainly get the conics and vector. Yeah, we should easily be able to get through 8. Definitely we'll get through 8, and we might get further than that. I don't know that we're going to get all the way to sequences and series, but we might. That's fun. I love sequences and series. It's great. In Calculus 2, you either have trouble with the processes of integration or sequences and series. I had trouble with methods of integration because I hate memorizing stuff. Sequences and series, you just have to think, and it's fun. Polar coordinates are awesome. That's a great unit. This is going to be a fun rest of the semester. Let's get back to trig. Oh, shoot. I took my thumb out. Huh, but I magicked. Okay, let's keep going. Let's do another example or two.
How long is this example?
What do you mean?
Like how many lines-ish?
I don't know.
Can I look at it?
Well, it's one of the guided practices, but the example for it is at the top of page 330.
I don't think I've ever had to use this much paper for a class.
Good. Good job, B.
Literally, I'm going to use all of our funky old paper and then get back
Nice.
to the clean paper.
Nice. Nice, nice, nice.
another example.
If we have time, definitely another 2 examples, possibly 4.
4?
Probably not. I don't think we're going to have time for 4, but we will have time for 2. We will have time for 2. Let's do which one? How about that one? 5A. 1 minus cosine x equals 2 times the sine squared x. And that's it. So, same instructions, all the answers in the interval 0 to 2 pi. So, what can we do? You're cheating.
Yes,
No
I
cheating.
am.
Yeah, so let me so we can understand without just looking at the example in the book. You do have to use identities. Why do we have to use identities on this problem?
We want the things to
Because
be
they
the
don't-
same.
Okay. Not the same number. So there's two issues. One is bless you. There's two different trig functions, which worked last time when we did one with two different trig functions because we were able to just totally factor one of them out and kind of make it its own thing. But we can't do that here. We can't factor it out. And so since we can't just factor one of the trig functions and make it its own thing, we need this to be one trig function and one trig function only. So how can we turn this cosine into a sine or this sine into a cosine?
The sine, if you move the 1 to the other side, could equal cosine squared.
I was thinking even before, okay, so let's go with your thought real quick.
I have a thought. We can square the whole thing to turn the 1 minus.
You'd have to square this too.
Yeah, if you square the whole thing, and then that turns into sine squared x.
But it'd be
Square the whole thing?
Yeah.
Yeah, because then 1 squared is 1, cosine squared is going to be cosine squared, but then you're going to have 1 minus cosine squared.
No. You have to, if you square the whole thing, you got to square the whole thing like that.
Oh yeah, and then it multiplies on this.
Yeah.
That was big spark.
You were, and I was trying to decide a little bit whether there was a way in which that actually does like get you to the answer. And it probably could. You know, identities are like that. You can you still probably would have to use identities later, but I think that is ultimately going to be a longer process. Yeah, but it could get us there. Okay, so we're not doing that. I was going to go with what you were saying, but that's going to end up with negative cosine, and I don't want to do that right now. Actually, let's do it twice. Let's do this problem twice. Here we go. Let's do it your way and what I would start with, what I would have started with. Because your way is not necessarily bad. So you're taking the 1 and moving it over, which is not necessarily a bad idea. We end up with negative cosine x equals 2 sine squared x. Oh, actually, your idea is not going to work.
Yeah, because that too.
Because we're going to end up with a 1/2. Because we've got to divide that 2 off. Yeah. So,
Or are you failing?
no, it's not going to work. Okay. So, right identity, wrong order. We can turn this one into cosine squared. Not just cosine squared, right? But we can turn this into 1 minus cosine squared. Right?
And then that is a 2 on the outside.
Yes. That squiggle is in fact a 2.
So I was in the right place. No.
Now what?
Factor that 2 out into the things.
Distribute it, you mean?
You know what I meant.
I did, which is why I confirmed with the words I confirmed with. Now what?
Move everything over to one side.
I agree. We're going to move all of that over to this side. We'll go ahead and write out this step. Why not? So we end up with 2 cosine squared x minus cosine x minus 1 equals 0. Now what?
You can factor that.
I bet we can.
It's 2 cosine x cosine x.
Or just 2 cosine, right?
2 cosine x and cosine x, yeah. And
Minus and a plus.
1 and 1. And it would be the way I wrote it, it would be a plus and a minus, right? So cosine x equals negative 1/2 and 1.
Wait, no, that doesn't work.
Yeah, it does.
trying to get a negative one.
2 cosine squared x. Oh, minus 2 cosine, yeah, I forgot the 2.
You follow? Yes?
What was the reasoning for the last step you just did?
What is the next step here? You tell me. When I get to this point.
Set that equal to 0.
Right, each one equal to 0, right?
You just skipped all of it. You just brained it.
Yeah.
Okay. So I was doing the right thing. I was just confused.
You were doing perfect. What is in my head right now? You were saying, my grades don't show that I am learning math. You understand what's on the board right now.
Yes.
Yeah, you do. So does 2 years ago of you understand this and can factor this with this ugly stuff? No, he cannot. You are getting better at math.
I'm getting better, that's true.
You're getting a lot better. There are plenty of kids that have your struggles in math that would have never taken pre-cal. I am proud of you for doing it. You're doing wonderful.
So now we do the,
Yeah, now we finish out the problem. Where's cosine negative 1/2?
Somewhere
here.
2 and 3.
Yeah, that one. 2 and 3, where is it 1/2?
Pi over 3.
Pi over 3. So where is pi over 3 reference angle in quadrant 2?
1 second.
would be 1 pi minus pi over 3, so it's 2 pi over 3.
Yes, it is. And then in quadrant 3?
4 pi over 3.
Yes.
Can you explain to me, like in 5, how we're getting those, like what is subtracting from what to get?
Technically, no, I can't explain to you like you're 5, but I can slow down. Yes. Okay. So let me give you the various puzzle pieces, right? You get the chart. Okay? And all you're looking at in the chart is the thing, not the sign, S-I-G-N, just the number, right?
Yes.
So you're looking at, okay, it's 1/2 over here. And up here at the top of the chart, it'll say pi over 3, yeah? Great. So that is the first one. Pi over 3 is here-ish. That's pi over 3. To find where it is, you have to use the reference angle. The reference angle is this one. And we're always referencing to the x-axis. So to find the one over here, it's the one that goes here, and this is pi over 3. One in this quadrant, it's the one from here, and this is pi over 3. One over here is the one that goes from here, and this is pi over 3. Right? And we do the SIGN with all students take calculus, right? So to get this is not quite back to 5 because you weren't doing fractions at 5, but close to 5. To get what this one is, what is right here? How many pi's is right here?
Pi.
1 pi. So to get right here, what you're actually trying to find is this one. So it would be all of this minus this. So pi minus pi over 3, which we're doing, which you learned probably in 4th or 5th grade. Turning this into 3 pi over 3 minus pi over 3, which gives us 2 pi over 3.
Okay.
And to get to this one, you have to do pi plus pi over 3. So that'd be 3 pi over 3 plus 1 pi over 3, which gives us 4 pi over 3.
Okay, I understand. How long were y'all doing that in your head?
Because I know that these have to match, and so 3 minus 1 is 2. 3 plus 1 is 4. Make sense? Good. I'm doing it in my head because I taught pre-algebra for a while.
You don't do that, yeah, you don't do that anymore.
Not as of this year, thank the Lord. Of course, now I have the headache of having to plan for electronics, which is eventually worth it, but it's a lot of extra work. Okay, so where is cosine 1?
It doesn't say.
0.
At 0.
Yeah. Wait.
Yeah.
Cosine 1 is at 0.
0.
Is it 0? Is it 0 anywhere else?
It's on the chart. Cosine is.
No.
You're right. You're right.
Oh, I reversed it, that's why. I have cosine and sine.
Because it would be -1 over there.
That makes sense. Power 2.
Are we out of time, kids? Is it time to sign some more homework and go? Pretty much.
I have a question.
I'm listening.
If the 1/2 wasn't negative, would we subtract the?
Oh, we should totally do one more example, but I'm actually listening to you for real now. What?
If the 1/2 wasn't negative, what would we subtract pi over 3 from? Or would we-
So it would be pi over 3, and it would be the one in quadrant 4. So it would be 2 pi over 3 minus pi over 3. Okay, yeah, this is gonna push us a little long. If you need to leave on time, go ahead, it's fine, not gonna hurt my feelings, it's recorded. But we should definitely do the last example because it's a type of thing that you have to shove stuff randomly into an equation. So we need to make sure we do one. Let's do cosine, yeah, let's do that one. That one's the cleanest. Cosine x equals sine x minus 1. This is a great problem. It's kind of almost funny. Okay, so we kind of have the same problem plus 1 as last time, right? What was our problem in the last example? What was the issue that we had to fix first?
Things weren't the same.
Yeah, the trig functions were different, right? Trig functions are different here, so use an identity to make them the same, right? Is there any identity that just like, without it being squared, just poof sine into cosine or cosine into sine? No, there isn't. So we're gonna do what you wanted to do last time. And we're gonna square both sides.
Yeah.
Wahoo.
We're gonna force some squareds on the population, which is kind of a pain, but it'll let us get rid of stuff.
And we can turn that cosine squared into 1 minus sine squared.
We can. And I'm gonna wait even to FOIL this out just for a half a second because I'm curious.
Can I write it like this, Sean?
Yes.
Is that legal?
No, absolutely not. Because that's not how that works, right? All right, that's a common mistake, right? So stop writing for a second so I can make sure you hear this good. This doesn't distribute. This turns into sine x minus 1 times sine x minus 1.
Yeah.
So you're missing a whole middle term if you do that. This one will turn into 1 minus sine squared x. Now we're in the same trig function, that's great. And we've got a quadratic, so we're probably gonna have to go ahead and FOIL this out. Dang it. Let's do it. Here we go. Sine squared times sine squared is sine, no. Sine times sine is sine squared. I am going to use, as time, you can write this all the way out and distribute it out on your paper if it makes more sense to you, that's totally fine. But I am gonna use our binomial squared shortcut because it's gonna make our life a lot easier.
First one and the second.
Can you write out what, like, the equation on the side? Isn't there like
Okay.
a?
I don't really need those parentheses, they're just obnoxious. Now what?
Subtract the 1 from something with the 1. Get rid of it.
Poof it!
It's annoying.
Oh yeah, it does totally poof, and it's a number, not a letter, so it's allowed. That's great.
Okay, so then we have negative sine squared x equals sine 2 sine squared x minus 2 sine x equals 0. And then we can divide it all by 2 because 0 divided by 2 is still 0.
Mm-hmm.
So then we're left with sine squared x minus sine x. And I'm stuck here. No.
Unstuck.
Sine x. Wait, where did stop 1?
I will, just for clarity's sake, especially since if anybody does watch this on the video, you won't be able to hear y'all very well. So if you divide everything by 2, the 2 goes away. You factor our sign out, and we get that. Right? Now what?
And then sine x equals 0 and sine x also equals 1.
True enough.
So then looking at the magical chart of secrets and magic, that gives us 0 and pi over 2 and 1 second. 3 pi
Wait,
over 2.
I'm gonna think with this, but I'm
Wait, why is it
gonna do it
pi?
extremely slowly.
I know you just said it, when we divided it by 2y.
To get rid of the 2's. Is it bad?
Oh.
Yeah.
Great. Thanks, Greg.
You're welcome.
Sine
Okay.
equals
Where is sine 0?
That's
oh,
0.
0.
Yeah, it is at 0. Why is this answer saying pi and pi over 2?
Well, pi over 2 makes sense.
Yes.
So it's 1.
Yes.
And then sine would be
I'm just trying to decide why they're saying it's also equal to pi. Didn't make a.
Because it's 0, because sine is
Oh,
y
yeah.
over r, and 0y is also on the left.
Yes,
And sine
yes.
is positive.
Yes.
why is it pi? I need my chart. Wait a second.
Okay, then the other one is. Oh, no, that's all of them.
Sine's
Yeah.
positive in the top 2 quadrants. This one's just pi over 2, and then it would be pi minus pi over 2, right?
Yes.
And that's just pi over 2.
Yeah. That's yes.
Pi over 2 twice.
Right.
The answer. 2. Where did we get pi from?
Because it's also 0 at pi.
Right. That is math.
So
Fantastic.
just those 3?
Just those 3.
Okay.
So it's 0 at pi. Okay.
Yes, it is.
Yeah, 'cause it's kind of like the
So that and another tool in your tool belt there that as you're, I mean, there's a lot like sometimes pulling these apart and thinking about them in all the different ways you know is helpful. Like, and I'll throw this out there. This is the tool in your mental tool belt. This is what sine looks like. Sine is it's 0 here and here for that matter. So actually, I wonder if the interval, they narrowed the interval further or something. Oh no, they included 0 and 2 pi, so I don't know why they didn't write those.
What is the homework?
The homework, thank you for asking, because we definitely need it. Like, I didn't really want it, but you need it, so you'll be fine. Is page 331, numbers 14 through, what is today, Thursday? Yeah, definitely do it. Do it! 34. 14 through 34 evens. Yeah, definitely.
The picture of the back of his head.
Before you cry over the weekend, there is one and only one problem where the answer is no solution.